In this video, we're going to learn how to verify inverse functions algebraically. So from the last video, we learned that if we take an input, which we generally call x, and we plug it into a function, we get an output. And generally speaking, we call that output y. And if we take that output and we plug it into an inverse function, it will undo what the original function did, and we will get our original input. So this relationship is generally written as such using function notation. So this means that we're taking our original x, plugging it into the original function, and then we're taking that output and plugging it into the inverse function, and we are getting x in return. Okay, so let's just clean that up. This is by definition. Now, we could also do that in a different order. We could take the input and we could put it into the inverse first, and then take that result and plug it into the original function, and we should get what we plugged in originally. Okay, so if we think of it in terms of our function machine, let's do it in a different color. We could either start up here and go into this machine, right, out of the original function, into the inverse function, and out, or we could turn it around and we could start here. We could plug it into the inverse function first. Okay, and then we're going sort of against gravity here, and then out of the original function. Okay, but either way, you get what you started with. So let's answer this question. Which of the functions is the inverse function of f of x equals 5 divided by x minus 2? So what we're going to do here, we're going to take this function and we're going to take, these are supposedly the inverse functions, right? This is supposed to be an inverse function, or this is supposed to be the inverse function. So they named these g of x and h of x. But what we could do is we could call this inverse function of f, maybe. We could call this the inverse function of x, the inverse of f, maybe. Okay, we're not sure. We're going to verify that right now. So let's take this inverse function on the left, part A, and we're going to substitute it into f of x, meaning we're going to do this. We're going to take g and we're going to plug this in to f. Or another way of thinking about this, we're going to take what we think is the inverse function of f and plug it into f. So the way this is going to look, we're going to take x minus 2 over 5, and we're going to plug it into 5 divided by x minus 2. So 5 divided by x minus 2. So x minus 2, that's our input. So that's where we're going to put this inverse function, x minus 2 divided by 5. And this creates an ugly mess that we then have to simplify. And when we simplify, if it simplifies to x, our input, then it is truly the inverse function. So let's try to do this here. So in the denominator, we're going to have to find common denominators here in the denominator. So I'm going to multiply, this is 2 over 1, I'm going to multiply that times 5 over 5, so I get a common denominator of 5. So this becomes x minus 2 minus 10 all over 5. Then I can simplify this to x minus 12 over 5. And now if I know I'm dividing by a fraction, so dividing is the same as multiplying by the reciprocal. So this becomes 5 times 5 over x minus 12. So this can simplify to 25 divided by x minus 12. Well, that certainly doesn't look like x. Okay, so this does not look like the inverse function. Just put a little frowny face right there. Okay, let's try this other option. So, again, we're trying to find f of h of x, which we're hoping is f of the inverse function of f. So we're going to plug in 5 divided by x plus 2 into our original function, 5 divided by x minus 2. So 5 divided by x minus 2 becomes 5 divided by 5 over x plus 2. Whew. All right, now we got to simplify this. If you haven't noticed, sometimes the algebra is a little intense when we're verifying algebraically. So in my denominator, I need to have, well, I was going to find a common denominator, but you know the first thing I'm going to do is I could see if I drop the parentheses, because I don't really need those parentheses there. This 2 minus 2 are going to cancel out to 0. So I'm going to be left with 5 over x in my denominator. And now 5 divided by 5 over x is the same as multiplying by the reciprocal. And we could see when I multiply by the reciprocal, this simplifies to x. So indeed, option B, h of x is equal to 5 over x plus 2, is my inverse function.